Esperamos a entrega no material físico, assim como as brocas e as fresas e a própria placa, para começar a produção da placa.
Bom dia, pessoal. Bom dia a todos. Desculpe o atraso, tivemos um problema técnico. Aparentemente, a gente precisa mudar o link da live. Se vocês forem no chat da live no YouTube, vocês vão ver o link onde vocês podem encontrar o novo stream. Então, está. Então, bom, acho que a gente já pode começar. Estamos ao vivo no YouTube. Eu gostaria de apresentar o palestrante que vai iniciar o dia hoje do nosso workshop. É o Dr. Kyriakos Georgiou. Ele é pesquisador associado sênior do Trustworthy Systems Lab da Universidade de Bristol, onde desenvolve técnicas avançadas de otimização e estimativa de consumo de energia para programas, incluindo modelagem de consumo, análise estática e técnicas baseadas em perfilagem. Kyriakos também trabalha no desenvolvimento de ferramentas e técnicas que podem fornecer garantias de confiabilidade de software e aprimoramento de segurança para sistemas críticos. Seus interesses de pesquisa incluem otimizações de compiladores, análise de código estático, otimizações de consumo de energia, verificação de software e segurança. Kyriakos possui um PhD pela Universidade de Bristol, um mestrado em tecnologia da internet com segurança pela mesma instituição e é bacharel em ciência da computação pela Universidade do Chipre. Colabora com pesquisa do Laboratório de Arquiteturas Paralelas para Processamento de Sinais, do nPITI, desde 2016, onde foi pesquisador visitante em 2018. Kyriakos, thank you for sharing your knowledge with us here today. It's a pleasure to welcome you. The mic is yours, please. Hi, we can still not hear you, Kyriakos. One second.
Hello.
Okay, now we can hear you.
Yeah, sorry, for some reason the connection went down for a second. Can you hear me clear now?
I can hear you.
So thank you for your invitation, Samuel. And I thank you for your words, and I hope you find this talk quite interesting. I shall share my screen then and
yes, please. Let's see if everything is working.
So I guess you can see my screen. So, as I said, today I'm gonna thank you for the invitation, and today I'm gonna talk about a theme that I think is very interesting and very relevant to our times. I'm going to talk about the potential threats of the Internet of Things. And I think the best way to start with it is to start with a brief history about the Internet of Things, which essentially was around for a few decades in the form of ubiquitous computing. The idea there was for computing to appear at any time and everywhere. And I believe this has been around at least for 3 decades. And then this started evolving in the last 10 years into what we call today the Internet of Things. And essentially what we are observing here is that we are trying to embed little computing devices in all kinds of objects in order to sense the environment, collect data, perform some basic computations, and transmit the data to the cloud for further processing. And essentially, this technology is really picked up in the last decade. And now we are seeing a new form of this IoT revolution, which is becoming the edge computing. And what we are trying to achieve with edge computing is to transfer more computations on the edges, essentially on the IoT devices, in order to save bandwidth and reduce latency from sending the data to the cloud and then processing them. And the main driver behind this is a machine learning evolution. And you can think, for example, a car parking slot application, which essentially you have a camera and it's taking a picture and you're trying to figure out if a parking slot is empty or not in order to be able to park or to know where there's empty park spaces. And essentially, you don't want to send that picture to perform the image recognition on the cloud and then wait for it to come back. You can now, with tiny machine learning algorithms running on tiny embedded devices, do that on the spot and get an answer immediately. So we also have to see a bit about the IoT application space, which is essentially enormous and is spanning to every modern industry. Healthcare, automotive, smart home, manufacturing, agriculture, oil and gas, you name it. Essentially, we're going to see IoT applications in every modern industry. And why is that happening? Because it optimizes operations and performance of business through automation. It creates new business opportunity. For example, smart home is something that we are seeing booming the last years. And it can also improve life quality. A lot of IoT healthcare-based devices are now targeting elder care. And of course, the main driver behind all of this is, as always, money. So let's put the IoT numbers by the lens of some global players into this technology. So ARM, the #1 hardware IP provider in the world, is estimated that 1 trillion IoT devices are going to be installed all over the place by 2035. And another ICT company, Gartner, is estimating that currently around 90% of the enterprise generated data is created and processed at the data centers and only 10% outside. By 2025, this will be a different story. So edge computing will amount for 70% of the creation of this data. And then another company, IDC, is predicting that by 2025, 175 zettabytes, which in a sense is 175 trillion of gigabytes of data, will be generated around the globe. And the edge devices will create more than 79.4 zettabytes of that data. And finally, ARM is predicting that IoT boost to the global gross domestic product by 2035 will be 5 trillion per year. This is huge numbers, so there is huge potential for this industry. But every time you have a new technology coming out, then of course you have a lot of challenges, especially when the technology has this size and the opportunities has this size. One of the main things that is a major challenge is embedded programming, because essentially all these devices are essentially embedded little IoT devices, which you have to use embedded programming to bring them to life. The problem with embedded programming is that it's not the mainstream. And I tried to find some figures, but essentially I end up that only a fraction of all the software developers around the world is embedded developers. And embedded software development requires a complex skill set, which has a steep learning curve. So beyond the common software engineering skills that every programmer has, an embedded programmer should also be able to do low-level programming. Often you are dealing with bare metal, no operating system, and you have to manually optimize your code, writing assembly code. And then you have to have extensive knowledge on hardware, especially on microcontrollers and sensors. And then you have to also have very good debugging skills. So you have to not just use an IDE to debug your code, but at the same time, you have to use oscilloscopes and logic analyzers to debug the hardware working together with your software. So beyond this, a good understanding of operating system, and especially the embedded ones, the RTOS is also needed. So these are skills that are difficult to acquire from the software developers that are in other development areas. And then why is the application development of these machines so complicated? Well, embedded devices are inherently limited in resources in terms of computing power, memory size, and energy budget. So at the same time, you have compilers which you are dependent on them to optimize your code. But the problem with compilers are that typically are optimized for larger systems like x86 or servers, processors that go to servers and data centers. So there is very few teams around the world and small teams that are actually optimizing your compilers to work better for embedded devices. So it's very hard for developers to optimize their code for such devices. And then you have other requirements, which is worst case time requirements. For example, a lot of critical IoT devices, they have to finish their task in a specific time frame. So for example, if you take, as an example, the brakes of your car, the brakes have a limited time that you have to respond. You can't have an unlimited time of response, otherwise it may be fatal. And then you have other things that are coming out the last years, which is like assurance, software assurance and security and data privacy. But is this really an issue? And this is what is the main point and discussion in this presentation. And we're going to pick up on this a bit later. So I want to stop a bit and talk about also the energy challenge, because this is also my main research area and it's a main thing for IoT devices. So how actually we power up all these devices? Because if you think about it, they are scattered in the environment or embedded in all kinds of objects. So there is no access to a power grid. And in many cases, there is no option of a battery replacement, because when you embed a machine, little IoT device, for example, into a wall in order to get the vibrations of the building, then there is no way of changing the battery. And then we end up with only an alternative, which is energy harvesting. And the caveat with this is that it's unreliable and limited energy source. So we need hardware. The good thing is that hardware innovation enable a lot of low energy budget IoT modules for IoT devices. For example, we have the Bluetooth Low Energy, which is a customized version of the normal Bluetooth, which has very low power consumption, and it's tailored for the needs of the IoT. But of course, more needs to be done in the software side of things, because at the end of the day, the software is what is driving the hardware. It's also responsible for the energy consumption. So in this area, yes, potentially what you have to do is to have feedback to the software developers in terms of their software energy consumption through energy modeling or energy measurements that they will, and that's way that you will enable energy aware software development. So we already have touched all these issues, and we have been working on solving these issues. But let's come back to assurance and security. How we thought through this well? Well, of course, no. I mean, when the IoT buzzwords came out, everyone became an IoT developer overnight. Companies saw a massive opportunity, which they rushed to capitalize on. And there was no consideration about assurance and security. And just to clarify what I mean by assurance and security, assurance is when your applications are robust, free from software defects, and are doing what they are meant to be doing. And then security, no entity can compromise, alter, access, or take control of the functionality of the application with a malicious intent. So have we seen this before? Well, yes, do not underestimate humans' inability to learn from history. We actually have seen this in ICT many times. For example, for mobile application development, when the smartphones came out and everybody, the development and selling of applications was open to everyone. Everyone became an app developer overnight. And of course, when you start rolling, everybody start rolling applications into the app stores, they were full of bugs and full of security vulnerabilities. And we spend lots of time, potentially years, updating and patching them to get them to an acceptable level of security and assurance. The question now is, can we do the same with the IoT applications that they are already out there? Well, no, because essentially IoT applications have some inherited limitations and differences from app development, from apps, web apps or mobile apps. Firstly, IoT devices are scattered across the environment and embedded in all kinds of objects, so it's very difficult to reach and replace. Then they have no hardware security features embedded in them. I mean, the ones that they are already out there installed for 10 years now. They have no updating mechanism in place. In many cases, they are not traceable, meaning there is no central way to trace which devices are using modules which had a security vulnerability. And another thing that is new and very complex is that the IoT devices are increasingly interconnected and interacting with each other and the cloud. So this makes them increasingly dangerous because they are unpredictably vulnerable in unknown ways, and potentially by compromising one IoT device can give access to many others. And this makes the problem even more hard to solve. So let's see a couple of attacks that were due to the IoT and secure devices. So in 2016, we had a major distributed denial of service attack with the name Mirai, which essentially it was a self-propagating worm made of two modules. The first module was a propagation, which essentially discovers and replicates itself on IoT devices. And the second module was the attack module, which essentially you had a server that was controlling centrally and coordinate all the attacks for these, the affected IoT devices. and it's estimated that the Mirai infected over 600,000 vulnerable IoT devices. These were mainly home routers and surveillance cameras. And among others, one of the world's largest hosting providers, OVH, was part of this attack. It was attacked essentially. And this was the largest DDoS attack ever on public record. So the problem now is that the malware source code is also available, and it used to create new attacks by hacking groups all over the world. And any idea of the origin of the most affected devices? Well, it happens to be in Brazil, actually. So yeah, there is indications that actually the attack was originated from somewhere on South America. Yeah. So another major attack that was discovered actually this year, 2020, by an Israeli IoT security company was part of, essentially was a critical vulnerabilities discovered on an embedded TCP/IP library. All the vulnerabilities were memory corruption based, for example, out of bounds writes. And they were so dangerous, actually, which some of the flows allow for remote code execution over the network and can lead to a full compromise of the affected device. So essentially, you can take control of any device that is using this TCP/IP library. You can think from healthcare devices, which is scary, printers, point of sale devices, video conferencing, even your coffee machine or your fridge in your home. So at least 11 big vendors came forward and said that they actually have these vulnerabilities into their products. But it's estimated that 100 vendors are actually affected by these vulnerabilities. The problem is that it's impossible to trace all infected devices, mainly because some vendors are even unaware that they have this problem into their devices, because essentially the software was pre-installed on devices of third-party modules, which they bought and use without knowing in their own IoT applications. And this has been around for 20 years. So some vendors are already out of business, but their product is still embedded all over around the world and in risk of getting some malicious attacks. So then we have the other issue, which is IoT and data privacy. So what is the main driver of IoT revolution? As we said, it's of course money. But where is the biggest value of IoT originates from? Of course, big data. So IoT will be generating 79.4 zettabytes of data in 2025. So this is where is the big money for the big companies. So essentially, whatever is left unknown by the social media platforms about you, the IoT is going to figure it out. Things like what is your health status, what is your eating habit, how many times a day you open your fridge, all this information, essentially IoT without your knowledge is gathering them, and they will be used in ways that we don't know in order to promote several products to you, or do some demographics or whatever the big companies are interested in. And the worst part is that these data are not only accessible by the companies that they are intend to access them, but also anyone that can have access to a secure, vulnerable IoT device can also have this data. So imagine an attacker getting the footage from your home security camera. You are installing that camera in order to protect you and for security reasons, but essentially it's becoming like a Trojan horse. So how are we addressing the problem? Well, the governments are slowly picking up on these issues. For example, we have the UK government, they pass a new legislation in 2020, this year, which is essentially say that all consumer smart devices sold in the UK adhere to 3 rigorous security requirements for the Internet of Things, which is all consumers' interconnected device passwords must be unique and not resettable to any universal factory settings. So forget about if you forget your password, you have the reset button on your router, which is saving the day. This is gonna go away now. And then you have manufacturers of consumer IoT devices that must provide a public point of contact so anyone can report a vulnerability and it will be acted on a timely manner. And then finally, manufacturers of consumer IoT devices must explicitly state the minimum length of time for which the device will receive security updates at the point of sale, either in store or online. So is this enough? Still, there is no universal body for IoT standardization. But I guess we can learn from other industries. So assurance and security standards for certification have been around for many years for other critical industries like avionics and rail systems, for example. And security standards and assurance standards essentially is a set of metrics and guidelines and rules which for a product to be certified, you have to provide evidence to the regulatory authorities that you achieved a satisfactory level of adherence against the relevant standards. And then when you succeed that, then your device will be certified in order to be able to go to the market. Of course, this is very expensive and time-consuming process for these industries, but remember that aviation, avionics, and rail systems and space these kind of applications are way more complicated than IoT systems. So what we can essentially do is we can apply similar standards, but into smaller scale and selectively for IoT systems. So only certified against relevant security standard software implementations of the TCP/IP library can be used in IoT devices that require networking. Or, for example, of course, not all the IoT companies and development companies should go for getting certifications for every possible thing, but there should be third-party companies that get the certifications for specific software and hardware IT modules, and then you can buy from them and use them secure and these secure modules in your project. So coming back to the standards, in a nutshell, when you have some security or assurance standards, you have to, let's take, for example, the software assurance and security standards. There are many standards also for hardware and networking, but let's focus on the software side. So in a nutshell, what you have to demonstrate is that your software is free from defects and vulnerabilities, and it's doing only what is meant to be doing. And this is boiling down to two areas: software verification and software validation. And software verification, in a nutshell, you describe it like, are we building the product right, which covers the first bullet point, which is free from defects and vulnerabilities. And then software validations, are we building the right product? So essentially this covers the part, is the product doing what is meant to be doing and what the specification of the product are telling us? But we have to remember that software bugs are also the source of most common and dangerous security vulnerabilities. So usually if we were in a normal presentation room, I will ask how many of you came across this corporation's common weakness in numeration. And essentially this is an organizational line which is just keeping update a list of software vulnerabilities that can actually be lead to security issues. And this table shows the 25 most dangerous bugs that can appear in your code. And I'm pretty sure that you all came across when you were writing a piece of code or an application, for example, out of bounds, or in out of bounds write or read, or unbounded loop and stuff like that. But you came across and something was not working on your application, then you fix it, and then you think everything is fine. But you never consider that actually, if I use different input cases, test cases into my program, I might have more of these bugs. So you just solve what you came across in order to typically to move on, and you say I'm done, but actually you never consider that your application might have many more bugs which you just didn't have, it just didn't happen for you to execute. So how do we actually test in our code, and how are we making sure that it's free from all these kind of bugs? Fortunately, there is a lot of software verification verification tools out there which they can help us with that. But keep in mind that software verification is very hard. In most realistic application, the input space is too large to be exhaustively tested by any traditional testing methods. So all these methods are just trying to do the best that is possible. There is a spectrum of available techniques coming from automated, manual, static, in the meaning that static analysis is performed on the code and there is no execution of the code. Then dynamic methods that you actually test in your code by running and executing. There is hybrid techniques. And I'm not going to go through all these different approaches, but essentially there is different types of techniques with different pros and cons. And I like this graph. I found this graph by Julian Cohen, and it's very interesting because two of the main most important aspects of these tools is if they're automatic or if they need manual effort to work. And then if they are dynamic, for example, if they are actually executing on the hardware, or you are performing some static analysis on the code to figure out things. And then on this axis, on this plot, we are plotting where each technique belongs. And for example, you can see on the right bottom side, then debugging, which it means that debugging needs a lot of manual effort, but is dynamic approach because you are actually executing the code. And then surprisingly, you have also grep on the left top corner, which grep is the well-known functionality of pattern matching in a file. But it's surprisingly, but many security experts are using grep to find potential vulnerabilities into your code by matching patterns of vulnerabilities. So there is a whole spectrum of tools that they can help us with that. And I'm gonna focus on two very trendy technologies right now, which they're making a big change in the industry. I mean, these technologies have been around for a while, but now they're really picking up. So one of the technologies is fuzzing, which essentially is automated testing. And the most known tools, open source tools from this is the AFL and AFL++ from Google. And in a nutshell, what is this doing? You provide some initial test inputs, which are your seeds. The fuzzer execute the code with this test inputs, and then it records all the paths through your code that it has visited. And then the fuzzer mutate your seeds, these initial test cases, to create new test cases cleverly in order to test the program again and then try to execute a new execution path that you didn't execute before in order to discover bugs in your code. And this is happening in the speed of thousands of execution per second till required coverage is met. And by coverage, I mean there is different metrics here. Coverage can be how many branches of your code you actually exercise, or how many statements in your code you actually reach with your test cases. And then you have another technique, which is called symbolic execution, and it's an automated verification technique. This technique, in contrast with the fuzzy, does not use concrete inputs to test the program, but symbolic values. Essentially, what it's doing, it kind of symbolically executes the code and constructs symbolic expression and constraints at each branching point, and then it uses constraint solvers to solve these generated expressions and create input test cases for all possible paths in the program. So, of course, these two technologies have their limitations, but if you put them together, there is actually, then you create actually a very effective tool for discovering this kind of software vulnerabilities from your code. For example, average guided fuzzing can explore the input space at almost native speed of execution. And it's very good for discovering inputs that lead to execution paths with loose branch conditions. For example, if you have x is greater than 0, this is a very loose constraint, and then the fuzzing will be able to find an input that will exercise this branch and then go into the branch to test your code. But concurrent execution, which is a form of symbolic execution, on the other hand, is very good at finding inputs that drive the program into tight and complex branch conditions. So, for example, here you have x is equal to something very specific. While the fuzzer will not be able to find an input case like this to test this branch, the symbolic execution will be able, because it's symbolically executing and is solving the equation that you created for this branch to get an input that can exercise it. But from the other hand, symbolic execution is very expensive and slow to form path constraints and to solve them. So what I want to say, this is two techniques that are becoming very major, and we should see them being adopted in the IoT space in order to make sure that your code reach a level of security and software assurance. So now my key takeaway from this presentation. IoT essentially is transforming the world rapidly and in unexpected ways. It can improve our quality of life, optimize business operations, and significantly contribute to the world's GDP. But at the same time, it poses a major risk due to its inherent security and privacy risk. We have been introducing a Trojan horse in everything around us for the last 10 years. And governments really need to step up and regulate the IoT industry. Ericsson is estimating that 5.7 million new IoT connected devices are established every day. So every minute without regulations, it really counts, because these IoT devices are there. Some of them have vulnerabilities, and also there is no control on the data that they're essentially recording and distributing. So a more immediate action can be taken by software developers and companies, which they really need to look into how to make their IoT devices more secure. And for me, IoT, the current status is the hacker's wonderland. And essentially, we created a massive playground for hackers. Thank you.
Thank you, Kyriakos. Thank you, Kyriakos. That was a very, very nice presentation.
I think I should stop sharing my screen now.
Yes,
or maybe leave it, because maybe we have questions.
Yeah. So we open up for questions. I will ask the audience to send questions in Portuguese. I will translate them to you, or if they can put also in English as well. Okay, just hang on a bit. Ok, pessoal, quem quiser fazer alguma pergunta para o Kyriakos, se quiser fazer em inglês ou em português mesmo, só cola no chat, por favor, que eu transfiro aqui a pergunta para ele. Meanwhile, Kyriakos, I would like to discuss a little bit what you talk. It's very challenging indeed to make IoT work with all those challenges, right? Energy challenge, the security challenge, assurance challenge. What do you think we can do in our curricula to make the new professionals, the guys who are graduating a few years from now, tackle this problem or be aware of it and be able to have to produce goods that are safe and that are usable in the sense of IoT. Is that something that we need to change completely in our curriculum? Is something that we can change bit by bit? What is your view on that?
I think there is courses like cybersecurity and software verification that they are targeting these kind of things. But I think what it really has to be done is to be put in context. For example, these kind of courses shouldn't be optional. They should be part of the software engineering main courses and part of them. So you have to get to the programmer or to the software developers the notions that when you're developing a software application, you should make sure that you taking care of not only just make it work for what you are testing it on your laptop, just a couple of test cases, but you should probably be aware of methods and verification tools and security tools in order to be able to get a level of assurance of your software application before you release it. And this is something that the most developers don't spend too much time. If it works, they think it works, and then they just push it as fast as possible. And I think
then it's just creating a snowball, because then that's going to be the playground for hackers is just going to become larger, right?
Yeah, I mean, IoT is already a huge playground. We have been installing around the world millions and millions, billions actually, of devices without taking care of these aspects. And now, there is no way of reversing it. So it's a problem.
Yeah. Do you think it's something that we should transfer to students early in the courses, or something more advanced that they need to be, for example, XIM programmers in order to start taking care into this?
Well, software engineering courses, I think most universities have them second year or third year. If you make them integrated in this kind of courses, then I guess it should be in early stages, second or third, second year, even second part of the first year of studies is a good idea, I think.
Okay. Sorry, I was a bit off. Okay, Kyriakos, thank you. I think we are approaching our time. Thank you very much for sharing all this knowledge with us. I think the audience and the people that will watch this video, because it's recorded and it's going to be available on YouTube for further consultation, they will be very happy to learn from the many useful information that you brought to us. Thank you very much. Just gonna say some words to the audience regarding the certificate that they're gonna receive for that. But and after that, I will close. Thank you very much, Kyriakos. Hope to see you very soon, personally, after this pandemic. I hope you stay safe, and I hope everyone else stays safe as well.
I wish you all the same, and thank you very much for your invitation and for your time.
Thank you. Ok, pessoal, muito obrigado pela presença de todos, pela participação aqui na live, na apresentação do Dr. Kyriakos Georgiou. Quem tiver interessado no registro de presença, tá, para um certificado, por favor, colocar o nome completo no no chat, e assim você terá o registro de presença para ter seu certificado de participação. É isso, muito obrigado e até a próxima, pessoal. Hoje à tarde tem sessão técnica, a segunda sessão técnica do workshop do nPITI, tá bom? O professor Pablo pediu para avisar isso. Então é isso, até logo, muito obrigado pela participação.